So you see, I executed one more command, docker system prune, that will remove all the stopped containers, all the network not used, dangling images, dangling build cache, and it deleted many things. So that was the part, that was the last command executed. And in this case, if you see, a lot of images were removed, and 647, that system prune command have cleared so many things. The system command will, docker system prune will clean up everything. So our system is ready. We need to install software, and we need to first open this file. This is docker under etc docker. The file name is daemon.json. This file is not available. I think it is available. We have to create it. It is a blank file. Yeah, we need to create this file. We need to create this file in all the three machines. Let me configure it and let me open this file in all the three machines. So on tester 1 also, on tester 2 also, and on server also. This file will have a single line. This line is execute option. And watch carefully, on day 1 installation, I told you that if you try this docker info, the control group driver was C group FS. Let me show you here. Oh, I saved it, but without restart I can show you. After restart it will change. So this control group driver, by default it is using C group FS. We need to make it system D, and this is to be done on all the three machines. So I'm making it on all the three machines, control group driver, saving it, and it is changed to this control group driver, but it will not be effective until unless you restart Docker. So let me show you without restarting first. Docker info, and you see the control group driver here with the docker info command. It is still C group FS. For Kubernetes, this driver should be systemd, and I have changed that, but it's not effective right now. So I need to restart Docker systemctl restart Docker. So after I restart Docker, the control group driver will be changed to systemd. It is mandatory for Kubernetes. This is Kubernetes requirement. Otherwise, when you initialize Kubernetes cluster, it will be complaining. It will give you a warning that control group driver is control group FS. It should be systemd. Now, if I try Docker info, you will see that control group driver is systemd. C group driver systemd. It is because of this region now. So in these cases also, we should trust that yes, control group driver is now changed. Next step is installing the software. We need to install the software on all the three machines, and the list of software is IPVSadmin, IP root TC, and Kubeadm. This is the main utility which will Kubeadm, which will provide kubectl also, CRI tools also, kubelet also, Kubernetes CNI also, that is container networking interface plugin also. So it provides a lot of things. So we need to install it on all the three machines. If you don't install these two packages, the initialization time, you will get a warning. So let us install on all the three machines. We need to install these packages on all the three machines because kubelet is provided by kubeadm only. So let's install this on all the three machines. All the three machines should have this IP root TC, IPVSadmin, and kubeadm, and the dependencies will automatically be installed. So installing the packages on all the three machines. After this is installed on all the three machines, so the installation is done on the server machine. So the next step after the packages are installed is you need to disable swap. The swap is not supported for Kubernetes. Kubernetes is will not work, will throw errors, problems if the swap is enabled. To disable swap, we need to open this file fstab, etc fstab, and the last line should be commented out with hash. So this will comment out the last line because last line contains the swap entry. So you need to disable the swap on all the three machines. So let me do it on tester one also. etc fs tab, the last line comment out. Same thing on the tester 2 also, it is still running, so no problem. So swap should be disabled. Then we need to use one command, mode probe bridge underscore net filter. This is a module, this is a kernel module to enable packet forwarding from your host machine to Kubernetes. So this must be enabled, the kernel module must be enabled, and then we should pass this value 1 to this file. This is a proc file system, that is process file system, under sysnet bridge and bridge net filter call IP tables. We need to enable this value by passing 1 to it. Same thing we must do on all the three machines. So let's do the setting. I hope the tester 2 is also ready. Yeah, vi/etc/fs tab. I need to disable swap, the last line comment out. And then mode probe bridge br underscore net filter, and on tester 1 also mode probe br underscore net filter, and then pass that value to proc file system, this file bridge nf call IP tables, and that same command must be executed on tester 2 as well. Now you can power off tester 2 because you have disabled swap, you have made some changes. So we are powering off the tester 1 and tester 2 both machines. Tester 1 also power off. Server also I can power off, but I will not do because I'll continue working with the server. Reason being, my server machine already have more than one CPU. Minimum requirement is you should have at least 2 CPU for the machine. But the swap is enabled right now when the system is running. The command is swap off -a. This will disable the swap when the system is running. So the swap is disabled. Number of CPU is more than one. Minimum 2 CPU is required. We have more than one CPU. That is, I have 3 CPU on this machine. Swap is disabled. So I'm good to initialize my cluster after opening the firewall. Firewall cmd -- permanent add port 10,248, 250, 252. This is the range of ports. Remember that there should be no space between comma and other values here. All the values are to be given in curly braces /TCP. This will open all the ports and reload the firewall. And then we need to enable kubelet. Systemctl enable --now kubelet. So kubelet is enabled. We need to pull the images. So kubeadm config image pull. This will pull all the images required for my pods related to Kubernetes to run. Although just like docker pull command, docker run command, if you don't execute docker pull before docker run will automatically pull the images before running docker run. So docker run is essentially docker pull followed by docker run. However, you can exclusively execute the command of pulling the images. So for Kubernetes, I'm pulling the images with this command. It should be images, not image. Kubeadm config images pull. To fix this issue, we need to open this file etc containerd config.toml, and in this file we need to disable this plugin. So comment out this line, rest all is okay. You don't even need to specify anything else. Let me restart my kubelet. container D, sorry, systemctl restart container D, and then if I try the image pull, it will work. Just disable that, comment out that one line, and it will pull the images. So this error can be easily fixed by opening this file and disabling that CRI plugin line, and see it is pulling the images. Okay, image pull is successful. Now we can initialize the cluster, Kubernetes cluster. And for that, the command is this kubeadm advertise IP address. I'll show you, I'll take back to you to the command. Advertise IP address and pod network. So advertise IP address, the way we did it in Swarm. This is nothing new. You know that if you don't specify this, it will advertise the first non-local host IP address, which is 10.0.2.15. So to avoid that, I have specified this IP address. Pod network is the overlay network for my pods, because I'm going to deploy a container networking plugin which will have this particular IP CIDR block. So I have to specify that right in advance. So this will initialize my cluster, and I'll get that join command here also, just like Swarm. So I copy this command in one of my notepad files so that I can execute it later on my tester1 and tester2. And then three commands are given here. We need to execute these three commands. First command is this. Sudo is not required because I'm already logged in as root user. And the third command is this chown. Now our cluster is initialized on this machine. You can start executing the command kubectl get nodes. This will show us the node. You see it is not ready state. If you add -o wide, this will give you more comprehensive detail about your nodes in the cluster. So you can see that my control plane node server.example.com version number 1.26 internal IP address this is not ready yet with this version running. Why it is not ready? Let's investigate. We can use kubectl get pods -o wide, and if you don't see, if you try this command, it'll say there is no pod found in default namespace. Namespace is logical grouping of resources. So by default, it will search the pods in the default namespace. So I need to specify all namespaces, all namespaces. So if you look at all namespaces, you will see one Kube system namespace is created, and under that you can see the services running. Scheduler, I was talking about proxy, I was talking about controller manager, I was talking about API server, etcd. You see that all these services are running properly. Only one thing is showing as pending, and that is core DNS. Why this service is pending? Because we have not installed any container networking plugin for container networking. We need to install those plugins. Once I install that one plugin, my this core DNS status will be running, and then my status of my node will also be in ready state. So to install the CNI plugin, we will open the browser. We'll go to the Flannel plugin page. It will show me the file. I'll create this file kubeflannel, whatever name does not matter. So let me create the file kubeflannel.yml, and I need to paste the content of that file which is open here. Yeah, this one. So this content I need to paste that. Direct command was given, but that command, because the raw content is not reachable because of GitHub, I don't know why it is working. Sometime it works, sometime it doesn't. So that's the reason I have given you alternate option. So paste it, but remember that you have to open it in the same browser, because you know what, if you try to open it in the host machine, then from here, see, it is not reachable. So from host machine, you will not be able to copy that much content. So ensure that you open in the virtual machine itself, and ensure that you open in the Firefox browser in the same machine, then only you will be able to copy it and save it, and then apply this file kubectl and file name kubeflannel.yml. So once you apply this, then the status of this core DNS will be running. And once you see everything is running, then only you will see the node status will change to ready. Yes, let's check the status now. Right now it is pending. Let's wait. It will change to running after some time. Just it will take 2-3 minutes. I know. Now it is initializing the flannel page. Init container is running. Sorry, init pod is running. So give it some time, and I'm deliberately doing it so that you understand that it takes time. It is not instant. Now one of this plugin is running. Flannel plugin is running now. So core DNS will also will change to running now, and see it is running now. So this Kube Flannel plugin, the CNI plugin is running. The core DNS is running. Now if I go to my pod status, that is node status, now you'll see the node is in ready state. So my server is now ready. My Kubernetes API server is configured and it's running. All the pods are healthy and running. That was the part 1 of this. Let's go for the session. So session 9 K8s or Kubernetes installation configuration and validation. Installation, initialize the cluster, set up pod network and validate the cluster. I have demonstrated these points just now. Installing Kubernetes on CentOS 8 or Oracle Linux 8. In Kubernetes setup, we have one master and multiple worker nodes. The cluster nodes are also known as worker nodes or minions. From the master node, we manage the cluster and its node using Kubeadm and kubectl command. And you will be using kubectl for remaining 2 days. Kubernetes can be installed and deployed using Minikube, that will be a single node Kubernetes cluster. Kubeadm, which is a multi-node cluster in your own premises. And the third option now is K3S, which is a lightweight Kubernetes cluster. The link to K3S, a single node lightweight full working cluster, the lecture recording is available on my channel. And just before this lecture, 3-4 lecture before this, there's a lecture on Rancher. The Rancher is a Kubernetes management system. And in first few parts, first 10 minutes, I demonstrate how to install K3S, that is Kubernetes lightweight cluster. Setting up the environment, disable SELinux and set up the firewall rules. So log into the server. You know that in my case, as I explained yesterday, my SELinux is already disabled, and that is disabled in etc SELinux config file. So if not, you can directly execute this command. To disable in the current session, you can execute this command. So stream editor, case insensitive, follow symbolic link and substitute SELinux is equal to enforcing with SELinux is equal to disabled globally in this file. That's how you read this line. That's how you understand this line. Set the following firewall rules. You can do these rules one by one, port by port, or in one go. So this is just again as an explanation that you can do it in one line at a time, one port at a time, or all ports in one go. Choice is yours. But you must reload the firewall after these ports are open. Then we also did bridge net filter probing of that kernel module to forward the packet from the host machine to the Kubernetes cluster. And then we also passed that value 1 to this process file system processnet bridge nf call IP tables. Local resolver is already configured on your machine, which is in etc host file. So in my case, it is 10.10.0.100 is the server, 101 is the tester 1, 102 is the tester 2 machine. Remember, those who have 8 GB machine, don't configure 3 node cluster, 2 node cluster will be sufficient. In worst case, if you want to configure single node, then I advise you to use K3S, that is lightweight Kubernetes cluster given on my channel. Disable swap in all node using swap of -a, or to permanent disable you need to go to this fstab file, etc fstab file, and then comment out the last line. Then the repository part, you know that we configured this repository. Uh, Point to be noted about the repository was that this last line is a single line. Sometime in conversion of Word to PDF, this line breaks into two lines, and when you paste it from the PDF, this line break into two lines, and that will throw error. You will not be able to install Kubernetes applications or packages. Install Docker, we have already done that. This is installing Docker and update that, and then install IPVS admin, IP root TC, and Kubeadm. Then restart Docker, restart kubelet, and enable kubelet. That's what I demonstrated. Then you initialize the cluster. The last command was docker or kubeadm init. Similar to Docker Swarm, we use the same command here, API server advertise address 10.10.0.100 and pod network cider block. This is a pod cider block, and this is one warning which is related to firewall, and I'm okay with this because I have already enabled all the ports, so it's not a challenge for me. Output of the command is like this only. Point to be noted is the three commands which are displayed in the output. Execute these three commands and copy this command in a notepad file, because this is the command which you will be executing on tester1 and tester2 to make them join the cluster. Use the cluster as a root. Yeah, these are the three commands which I'm executing here, and then I executed get pods also, get nodes also, and this was not ready state, point to be noted. So, and if you see the same output, we could see that core DNS was pending, rest all services were running. That was the initial demonstration. After that, we set up the pod. This is the command to enable and install pod network plugin, that is CNI. Point to be noted, in the lab assignment I'm using Flannel. In the presentation I'm using View. That really does not make any difference, because you can use, there are 4-5 different type of plugins, CNI plugins available. You can use either of them. So that's the purpose here, just to give you that idea that you can have any of them installed. Verify that it is running. So you will see that get nodes, and the output of get nodes command should be ready, and which was ready in ready state after 2-3 minutes. So this is on nodes, worker nodes. So worker nodes will also be done in the similar manner. So let me just explain and finish this off so that after that I can demonstrate that also. So this is same thing, SELinux, firewall, net filter, exactly same set of commands which you have executed. Now it is third time revision. First I demonstrated, second I executed the same command on server and discussed in the presentation. This is the same thing coming here also. Configure repositories, same worker Kubernetes repository we configured on the worker nodes also, and then installed this Docker repository. We installed the Docker on worker nodes, that was already there in our case, and enable Docker. There's nothing new. We executed these commands yesterday, that is installing Docker on worker nodes. And then you execute the join command. The join command which we have noted in our notepad file, we need to execute that command. So output of this command will be something like this node have joined the cluster, this one. This node has joined the cluster. Interestingly, I have not used that IPVC admin and TC, and that is why I'm getting 3 warnings in this screenshot. Deliberately I have not removed it. And first warning, if you look at little carefully, is C group FS as Docker control group driver. It is recommended that it should be systemd. So I changed that to systemd. That's why in my case I was not getting this warning. Second was TC not found. So I installed TC also. That warning was also addressed in my case. And the third is firewall. In my case, I already configured all the firewall settings or firewall rules. So there was no problem in my case that everything is great. In my case, all the services are running and there was no warning except the firewall, for which I already opened the ports. So now you can use the kubectl get nodes command, and you will get comprehensive details about your cluster using kubectl describe nodes, more comprehensive output. There are few troubleshooting commands like kubectl get pods namespace kubesystem -o wide, or describe nodes, or cluster info dump, that will dump the cluster information for troubleshooting. More on token and nodes. By default, the token will expire after 24 hours. To create the token, you can use kubeadm token create. If you don't have the discovery token hash, which is required in your join command, you can get it using this. Controlling your cluster from machine other than control plane, you need to copy the admin.conf file wherever you want to locate, wherever you want to manage. This file is required by kubectl command, like copy scp. Copy this file from the current machine to wherever you want. This is current directory of your destination from where you want to manage. And then you specify kubectl kubeconfig file admin.conf, and then you use get node. In other words, kubectl command requires this admin.conf file in order to work with cluster. That is why we did it by creating a directory with the name .kube and copying this file inside that .kube directory, which is the default location. If you specify that .kube directory and put this file into that, then you don't need this parameter. To remove the node, you can use kubeadmin reset, kube drain node name, delete local data, force, ignore daemon sets. And if you want to retrieve the join complete join command, you can use this print join command. You can watch the recording at this link. So let's log into tester1, tester2. I restarted my tester1, tester2, nothing else. Now we configure the firewall rules and reload the firewall on tester1 also, and then tester2 also. This is tester1 executing the firewall command on tester1 and reload the firewall. And we just need to run the kubelet systemctl. In fact, we need to edit that file also, /etc/containerd config.tml, and we need to comment out this line. Same thing we must do on tester1 also, or tester2 also, /etc/containerd config.tml, and we need to disable this line because this is creating conflict for us. And now we need to restart containerd systemctl restart containerd on tester2 and on tester1 also, systemctl restart containerd, and then I'm good to go with kubelet systemctl enable --now kubelet, and I need to do the same on my tester2, systemctl enable --now kubelet, and we just need to execute the join command now. This is a join command I copied. So let's execute the join command on tester2 and on tester1, both machines. So this node have joined the cluster, this node have joined the cluster, and now we can check that nodes -o wide. Initially you are getting not ready because it will be provisioning some pods, and you will get some container creating, pods creating status. You see kube proxy container creating, and these are kube flannel initializing for tester1 and tester2. So once I see all these pods in a running state, then my cluster will my nodes will also be in running state. So right now it is creating containers, pods, sorry, workers. So let's verify once again. Yeah, this is still initializing. All are running. Now I can see my nodes should be in a ready state. Now the roles part, as far as tester 1 tester 2 concerned, you can see that there is no role. So to change this, we just need to change the label. So this is the command kubectl label node tester1.example.com, and the role should be worker. And same thing I'm doing for tester 2 as well. And it is labeled. Now I can try this get nodes -o wide. Now you see the labels also worker nodes. So we have successfully installed and configured a 3-node Kubernetes cluster in our local environment. That's all for this session.